In this lecture, we're going to look at a third API, which is Socrata, which is commonly used by cities, other government agencies, nonprofit organizations to make their data available via the web. So we're going to demonstrate this API, and we'll also look more at pandas, geopandas, and how to plot information using those libraries. Just like the census, you can call Socrata APIs with requests. There's also a dedicated package called SodaPy, which I'll mention briefly in a moment. But let's start with one example. This is from the city of Los Angeles. This is their housing dataset on affordable housing projects. So really useful if you're doing anything in housing policy. Now, if you click on the API button in the top right corner, we're going to see lots of useful information. So we're going to see the endpoint here, which is the URL, which we can copy and paste in. We can see more detailed documents, and we can also see which formats are available, so JSON, GeoJSON, or CSV in this instant, as well as a preview of what columns there are, what the data look like. So I copied and pasted that API endpoint into this URL. So we're going to just use requests to request the information in that API from the City of Los Angeles website. So we're going to create this R object as we did before, and we've seen this syntax before. We're going to use JSON loads to pass the text of that response and see if we can put it into a pandas data frame. And it looks like that works. We get all the columns that we were expecting that were on the city's website. So we might have expected some geographic coordinates here. And it looks like they are here, but they're in this column called geocoded. So it's not, right now it's not spatial data that we can plot, but all the information is available there. So we converted this to a regular pandas data frame, and that doesn't understand spatial relationships. So we could either try and parse this geocoded column, or we can look back at this web page here. And we saw that there's a GeoJSON option as well. It has the same URL, except it's GeoJSON rather than JSON. How do we make use of this? Well, we don't even have to go through requests. GeoPanda's read file can read in the information from the URL directly without having to go through requests. So let's do this. This is the same string that I copied and pasted from the city's website, and we're going to pass this into a geodata frame and look at the first 5 rows. Okay, and we see the same information as before, but we are going to have a geometry column. When you get geographic information, the first step is always to look and see what projection this is coming in. And this is in GeoPandas using the CRS attribute. So here we can see this is the EPSG code 4326. And there's a lot of these, but there's 1 or 2 that you really should memorize. 4326 is one of those. This is latitude, longitude, unprojected data. And there's a little more detailed information here as well. But fundamentally, we know that we're getting information back in degrees, and these are latitudes and longitudes. So that sounds fine. Let's plot this. So all this is doing right now is plotting the locations of these affordable housing projects. And there's an outlier here that could be an error. We might want to look more closely at that. But all the others are clustered at latitude minus 118.5-ish and a certain latitude. So far not helpful, but we're going to clean up this map. But before I do that, I want to mention 2 other ways that we can read this data in, rather than using the Socrata API. But one is SodaPy. We're not going to cover it here. You can follow the link. It can be simpler for some types of data set, but note that it's no longer maintained as of August 2022. The other option is simply to save to disk. You can point and click on the web page, download the file to your computer, and load it in. And Socrata here gave us different options to download this file, to export. I chose the shapefile and downloaded it to my downloads file. So you can change this path. This is my downloads path. Change this to wherever you download files on your computer. And I'm going to use GeoPanda's read file, the download path, plus this file name, and we get exactly the same information as we did from the API. So let's clean up this map that we created. First of all, we can plot the data frame directly without pre-creating an axis, but we have more flexibility if we create our own figure and axis objects using the matplotlib, the subplots function. So we're going to also plot the data in a particular column. How about the number of units on this site, the site units column, as a proportional circle? And then we're going to add a base map too, using the very nice contextually library. So let's walk through this. We're going to do our imports contextually in matplotlib. If we try and plot site units straight away, and you should try this, we're going to get an error because there's some 0-unit entries that aren't coded as numeric. So we can convert this to an integer. We're going to create the same column name, site units, just overwrite what's there already, with site units as type integer. Let's pre-create our axis object. And then we're going to need to reproject, because typically contextually will give us a base map in Web Mercator. This is a second EPSG code that you should try and remember. 3857, that is Web Mercator. It's a de facto standard for much of the plotting on the web. So let's reproject our data frame. We're also going to use this little filter to only plot the entries where there's at least one unit. So I'm going to do a filter where the site units column is greater than 0. This will give us a Boolean list. Then I filter our GDF, our geodata frame. Try this out step by step if you don't follow each aspect of what I'm saying. Then we're going to reproject this using the toCRS function, which reprojects it from lat long 4326 to 3857. Then I'm going to plot it. I'm going to tell it I want the marker size to be proportional to our site units column, and I'm going to use this ax object that I created here. And then we're going to add a base map on this axis object. The zoom equals 12. I found that by trial and error. And then the final thing we're going to do is take off the tick labels and see what happens. Comment these two lines out and see what it looks like if you don't have these two lines. What do they do? Contextually sometimes can take a while to render the information, but we are hopefully going to get a nice map of our affordable housing data. Okay, so we see a nice base map and the number of affordable housing units marked by these proportional circles. And again, we have this this point. This could be an error. We'd want to take more of a look at it. We might also want to delete this from our data frame so that we can just focus on the core city of Los Angeles. So the takeaways I'll leave you with is that government open data sites, this isn't just an LA thing, they often use Socrata. And there's a very high standard for documentation in most cases. They explain they have good metadata, they explain what the columns are, and they give you several options to import it into Python, whether using the API or through downloading the file to your hard drive. And projections matter. The number one thing that goes wrong if your map doesn't look right, you've probably got the wrong projection. So when you bring some data in, always look at the coordinate reference system using the CRS attribute.